least common multiple, which is also known as what? LCM. The reason why this topic is still under numbers and numeration. Don't get me wrong, and that's why I included it. Even the highest common factor, we are going to discuss it. But I tell you, some students in secondary school, even in higher institution, they are still having issues with SCM. I tell you, once you get the foundation, the basis, as far as mathematics is concerned, if you understand the basis, generally in life, if the foundation is solid, definitely the structure that you are going to build upon the foundation will be what? Will be solid. What do we mean by least common multiple? The least common multiple of two or more numbers. The least common multiple of two or more numbers is the smallest multiple common to the given numbers. Yes, the least common multiple of two or more numbers is the smallest multiple common to the given numbers. When you say common, definitely you are going to be looking at two or more. You want to bring out what is common among them, between them. Is that taken? So, lowest common multiple is the what? Is the smallest multiple that is common. Is that taken? Among the given numbers. So, example, they ask us to find the LCM of the following: A, 2, 3, and 5. B, 10, 12, and 30. C, 2 raised to power 2 times 3 times 5. 2 times 3 raised to power 2 times 5. 3 times 5 raised to power 2. And D, we have algebra. Yes, this is algebra. Don't worry, I'm going to take algebra. Math is wide, I have a lot to drop. That is why I said, please subscribe to my channel. Is that taking ID space Maths Doctor, so that whenever I drop a video, you'll be notified. So this is algebra, and we are going to find the LCM of this. So quickly, let's go there. Solution. The first question, we have 2, 3, and 5. I'm going to use more than one method here, but every other one I'm going to stick to one method. Now, multiples of 2 are what? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, okay, 22, 24, 26, 30, 32, and so on. Multiples of 3. We have 3, 6, 9, 12, 15, 18, 20, 21, 24, 27, 30, 33, 36, and so on. Okay, multiples of 5. We have 5, 10, 15, okay, 20, 25, 30, 35, 40, and so on. Now, when you look at the multiples of 2, the multiples of 3, and the multiples of 5, let's say 6 is here, 6 is here, but there's no 6 here, so it's not common. After 6, what is common again? Oh, 12. 12. Oh, hey, there's no 12 multiples of 5. After 12, there's 15 here, but there's no 15 in multiples of 2, so you can use that. 18. When you look through, you go through everything. I tell you, the lowest common multiples of what? 2, 3, and 5 is what? Is 30. That's it. Because there's a 30 year, there's a 30 year, there's a 30 year. So that is the SCM. I said I'm going to use more than one method. Yes, I will use more than one method. Or you can use this concept 2, 3, and 5. You use the number, you'll be writing here numbers that can divide this without remainder, that can divide any of them. 2 can divide. And let me say this, the numbers you'll be writing here must be what? Prime number. I've discussed prime number earlier. I discussed what? Prime number. You don't write let's say 4 here or 6 or 8. No, prime number. So 2 can go. 2 divided by 2 is 1. 3 divided by 2, there will be a remainder. So we don't bring in decimal. So just write the 3. Then 5 divided by 2, bring the 5 forward. No need of using 2 again, and you cannot use 1 because 1 is not a what? Prime number. So we use 3. 3 divided by 3, 1, and 5 divided by 3. You have decimal, so you write the 5. The next one we are going to use is 5. 1, 5 divided by 5, 1. Therefore, LCM is equal to, you multiply the prime numbers you have here. That is 2 times 3 times 5. And that gives what? 30. I love mathematics. It's very, very sweet. I believe this is not a problem. It's not a problem. Note, once again, the numbers you must write here must be what? A prime number. And try as much as possible to ensure that what? Ensure that the numbers here are in a kind of ascending order. That is, it is not proper you use 5 before using 2. So just stay calm and step by step before you know what is going on. You get the answer at ease. Question B. They ask us to find what? The LCM of 10, 12, and 30. Permit me to use this method because it's just so simple and direct. Yes. 2 can go. And 2 can even divide everything, but I tell you 2 can divide. Even if it is one of the numbers, okay, that 2 can divide, you just have to start with 2. But when you look through the number and 2 cannot divide any of them, you consider 3. If 3 cannot divide any of them, you consider 5. 5 cannot divide any of them, you consider 7. The numbers must be what? Must be prime number. So 10 divided by 2 is 5. 6. 30 divided by 2, 15. 2 can divide 6. You see, you use 2 again. 5, 3, 15. Any number that when you divide will leave a remainder, just bring the number forward the way it is. 3 can go because we have this and this. Even if it's only this, we are going to use 3 now. So 5, 3 divided by 3, 1, and 15 divided by 3, 5. We use 5. That gives us 1, 1, 1. So the LCM is equal to what? 2 times 2 times 3 times 5. And that is what? 2 times 2 is 4. 4 times 3, 12, and 12 times 5, 60. So the LCM is 60. 60 is multiple of 10, 60 is multiple of 12, and 60 is multiple of 30. And this is the least common multiples. Just the way 60 is the multiple of these three numbers, 120 is multiple of the three numbers, 180 is multiple of the three numbers, and so on. Because there are some questions, they will tell you list the first three common multiples of, let's say, 10, 12, 30, or the one I solved here, 2, 3, and 5. Once you get the LCM, don't bother yourself to start thinking, they asked me to find the first three common multiples of. No, don't stress yourself. So once you get the LCM, for instance, the LCM of this is what is 30. Just multiply the multiples of 30. Okay, 30, 60, 90, 120, 150, and so on. But the question says what? You should list the first three multiples. The first three multiples. The first three common multiples of 3, of 2, 3, and 5. Or the first three common multiples of 10, 12, and 30. How do you go about it? Once again, once you get the LCM, which is the least common multiple, once you get the answer, just find the multiples of the answer. To the next question, C. We have 2 raised to the power 2 times 3 times 5. Okay, we have 2 times 3 raised to the power 2 times 5, and we have 3 times 5 raised to the power 2. How do we solve this type? Instead of you to change this to, 2 raised to the power 2 is 4, because it implies what? 2 times 2. Then 4 multiplied by 3 will give 12. 12 multiplied by 5 will give us 60. 2 times 9, because it is 9, that gives us 18. 18 multiplied by 5 will give us 90. Is that taken? This is 60, this one is 90. Then 5 raised to the power 2 is 25. 25 multiplied by 3 will give us what? 75. Instead of you to now find the LCM of 60, 90, and 75, you can just get the LCM direct like this. All you do is this: LCM equal to, you look through the number. The lowest among all the numbers is 2. You look for the highest power of 2. Like we have a 2 here, the power is 1. We have a 2 here, the power is 2. So the one with the highest power is the one you will pick. Times the next number after 2. The next prime number you can see after 2 is what? 3. The power of this 3 is 1. The power of this 3 is 2. The power of this 3 is 1. So you pick the one with the highest power. That gives us 3 raised to the power 2. Then when you look at the 5 raised to the power 1, both are raised to the power 1. Why this one is raised to the power 2? So you pick the one of raised to the power 2. Note, just like the 2, you discover that here there is no 2 as the base. Is that okay? We only have 3 and 5 as the base. So it's not necessary that the 2 must be common to all among all the numbers. No, is that okay? Must be common to all the numbers. So because I'm saying this just because you have a 3 raised to the power 2, 3, you now think, oh, what you are going to pick must be common to all. No. Is that okay? So the LCM now is going to give us 2 raised to the power 2 is 4, 3 raised to the power 2 is 9, and 5 raised to the power 2 is 25. Okay? If you do 25, there's a way we multiply at times. When you do 4 times 9, it gives 36. Okay, 36 times 25 how do I get it? You start looking for your calculator, you want to work it out using your long multiplication. But I tell you, at times you just have to skip a number because multiplication and addition, they are both commutative in mathematics. What do we mean by commutative? 2 times 3 gives 6. 3 times 2 is also what? 6. So in this case, I'm going to say 4 times 25. That will give me 100. Very simple. So 100 we now multiply 9. That means the LCM is what? 900. Is that clear? The LCM is 900. The LCM of these numbers, this set of numbers, which if you do the other way around, but it's a long process. In fact, they want you to use this is another way of finding LCM. I can change this to index form, these numbers to index form, is that taken, and use this approach. So we have 3 methods for finding LCM. The first one that I list the multiples. The next one that I did was I used this format and this particular one. Is that clear? Question D. We have to find the LCM of what? 2x squared y, 6xy squared, and what? And 5xyz. Let's use this concept. Okay, 2x squared y, 6xy squared, and what? 5xyz. First, we are going to put the coefficient into consideration. We are going to put the coefficient into consideration first. The coefficients here are what? 2, 6, and 5. Is that taken? 2 can divide. This divide by this, these 2 will cancel out this. We are going to have left just x squared y. 6 divided by 2 is 3, so we have xy squared. 5 divided by 2, there's going to be a remainder, so you will write 5xyz. We look at the coefficient now, we are left with what? 3 and 5, so we use 3. That gives us x squared y, xy squared, and what? 5xyz, because 3 divided by 3 is what? 1. The next we are going to use is what? Is 5, so that we get rid of the coefficients. Then after that, we now start dividing by the what? By the variables, by the letters. X squared y, xy squared, and what? xyz. In alphabetical order, let's take x first. X squared y divided by x. This x squared means what? X times x. Okay, x squared means x times x. So when you divide by x, we are going to have an x left. So we have xy. If you divide this by this, we are going to have y squared. Okay, y squared. If we divide this by this, we are going to have what? yz. Is that taken? Then we still have an x left, so we use x again. Xy divided by x will give us y. Y squared divided by x, you write your y squared. And yz divided by x will give us what? yz. We move to y. There's no x again. We move to y. Y divided by y, 1. Y squared divided by y, y. And yz divided by y will give us z. We are going to use y again because of this. So we have 1, 1, z. And finally, we are going to use what? Z. 1, 1, 1. So the LCM equal 2 times 3 times 5 times x times x times y times y times z. And the answer is 2 times 3 is 6, 6 times 5, 30, x times x, x squared, y times y, y squared, and multiplied by z. We are going to have what? 30 times x squared times y squared times z. Removing, multiply this, our answer is going to be 30 x squared, y squared, and z. Yes, that is the answer to the question. Maths is interesting, very simple. All you just need to do is to understand the concept behind the question at hand, then apply the techniques, apply the formula. It's just like if you want to unlock a door, you need to insert the right key. If you don't insert the right key, the door will never open. So questions in mathematics are just like a locked door, okay? A door that is locked. So if you want to open it, you need to insert the right key. Example 2. Find the least number which, when divided by 6, 9, and 12, always leave a remainder of 3. We have to find the least number, least common multiple. In fact, looking at this question is somewhat different from the first example one I treated. The question is in form of word problem, but I tell you, you just need to calm down when you are reading through the question to get what the question is asking you to solve for. Find the least number. And what are we talking about here? Least common multiple. So what we are going to do here is to first find the what? LCM of the three numbers. The LCM of the three numbers. That is LCM of 6, 9, and 12. Let's find the LCM quickly. 2 can go. 6 divided by 2, 3. 9 divided by 2, we leave a remainder, so we bring forward the 9. 12 divided by 2 is 6. We can still make use of 2. We have what? 3, 9, and what? 3. 2 cannot divide any of this number without remainder, so we use 3. This divided by this is 1. 9 divided by 3 is 3. And 3 divided by 3 is 1. Then again, we make use of 3. And that gives us 1, 1, 1. So the LCM equal what? 2 times 2 times 3 times 3. 2 times 2 is 4, times 3 will give us 12, and 12 times 3 will give us 36. This is the LCM. But the question is this the answer to the question? No. The question did not ask us to find the LCM of 6, 9, and 12. No. They said we should find the least number. There's a particular number that when you divide the number by 6, by 9, and by 12, it will always leave a remainder of what? Of 3. The least, the lowest. Is that taken? Now, since the number when divided by 6, 9, and 12 always leave a remainder of 3, what you just do is the number now equal 36 plus 3, which is what? 39. 39 is the answer. Let's check. When you divide 39 by 6, is that taken? It's going to give us 6 remainder 3, because 6 times 6 is 36. So remainder 3. When you divide 39 by 9, it's going to give us 4 remainder 3. because 9 times 4 is 36, remainder 3. Similarly, when you divide 39 by 12, it's going to give us what? 3, remainder 3, because 12 times 3 is what? 36, and leave a remainder of 3. So the least number, the smallest number, the lowest number that when you divide by 6, 9 and 12, we always leave a remainder of 3 is what? Is 39. At this point, before I say goodbye to LCM, let me state this. This LCM, note that the LCM of two or more numbers is always greater than the given numbers or the highest among the numbers. Look at what I mean. The LCM of 6, 9 and 12, okay, happen to be what? 36, which is what? Greater than the numbers. And also, the LCM can be the highest among the given numbers. For instance, if you are to find the LCM of 4 and 12, the LCM is 12. Is that taken? So you see that the highest happen to be the LCM in this case, because some students, because the LCM of 3 and 5 is 15, they believe, or they now have it in mind that yes, whenever I'm asked to find the LCM, all I do is I multiply. No, it is wrong. Yes, LCM of 3 and 5 is 15 if you use this method. So you are not multiplying. So those students will now have it in mind that, oh, LCM of 4 and 12 is 48. 48 is multiple, common multiple of 4 and 12, but it's not the lowest, it's not the least common multiple of what? 4 and 12. I can show you LCM of 4 and 12 is what? 12. We used to, remember the number here must always be what? A prime number. That gives us 2 and 6. We use 2 again, 1, 3. We make use of 3, 1, 1. So the LCM equal what? 2 times 2 times 3, and that gives us what? 12. So the LCM can be the highest among the given numbers, or can be what? Can be greater than the given numbers. LCM of 3 and 5 is 15, is greater than the given numbers. While LCM of 4 and 12, LCM of 3 and 6, for instance, will be 6, which is the highest among the given numbers.